I'm Huachuan Wang. My research mainly focuses on the steam workbench 2, the structural safety for legacy mineshaft submarine storage. And we know that the legacy mineshaft is a promising structure for submarine storage. However, it is reported that there are on average 15 mineshaft collapses occurring in UK every year, which means that not every mineshaft structure could be safely used for the submarine storage due to the structural degradation. So which brings us about 3 key questions. So whether legacy mineshafts are safe to be used before the submarine storage, and whether these structures are safe or not during submarine storage operation, and how long these structures can be used for the thermal storage purpose. So in order to answer these questions, the 3D numerical modeling was conducted on the multi-hull number 2 mineshaft and the Barney number 3 mineshaft as case studies. And we take into account the shaft diameters like the shaft geometries like diameter, thickness, the depth, water level, and stratigraphy into our model. And the numerical simulation results before the submarine storage shows us that the structural stress increases with the shaft depth, and it also is affected by the weak rock layers like the coal seam and the fault zone, which means that the structural stress status will be highly dependent on the shaft depth and also the stratigraphy. And when the landing material strength decreases due to the degradation, the risky region of the structure could expand from the bottom, so which means that the landing material properties would be very important for the structural safety. However, we are still not clear about the current status of the landing material. And during submarine storage, for example, as an open-loop storage scheme, the water level would change during the thermal water injection and extraction. The structural stress shows that the structural stress reaches the maximum in case 2, where the shaft is empty, but the minimum stress could be achieved in case 1, when the internal water level equals to the underground water level. So, which means that the water inside the shaft can actually help the mineshaft to achieve to balance the structural stress and to help with the safety. So, which means that the closed loop scheme is relatively safer than the open loop scheme in terms of the structural safety. However, when we take into account the operation service life, the question could be more complicated. For example, during submarine storage, the water level change could cause the cyclic water pressure on the structure, and the temperature fluctuates, for example, from the 15 to 55 degrees, which will cause the thermal stress of the structure, and also the chemical ions like the sulfite in the mine water would also cause the corrosion of the landing materials. And these factors would interact with each other. For example, the water level change would affect the heat transport and ion migration, and the temperature fluctuation could accelerate the reaction rate of the corrosion process and also affect the water pressure. So which means that this factor interaction would further accelerate the deterioration of the landing materials and also result in the reduction of the service life. So, give a brief summary, there are still some challenges to be considered and to be solved. For example, we are still not clear about the current status of the structure and the concrete in legacy mineshaft, and we are still have no idea about the material deterioration process under the multi-physical environments. Also, the durability and service life of the structure need to be further investigated. So correspondingly, we need to do the set investigation like the CCTV camera and also the concrete sampling, and also we need to lab test to know more about the status of the legacy mineshaft structure and materials. And also we are establishing a multi-physical experimental system to replicate the real submarine storage environment and also to investigate the deterioration process of the landing materials. And finally, based on the experimental data, we can further calibrate our numerical model to better predict the service life of the legacy mineshaft structure. Thank you.